This
I hope you
conference will now
people,
be recorded.
am I not audible? Chaitanya is saying no screen, no audio. Okay. Okay, fine. So we started understanding how CLCD is going to work in the previous class. So first of all, CLCD comes with its own microcontroller. There is a separate microcontroller on the CLCD as well. So we started programming the CLCD in the previous class, being on the big microcontroller. So you have to initialize the microcontroller of the CLCD. You have to do operations onto the CLCD with the help of the program which has been running on the PIC microcontroller. So you saw how CLCD will be able to accept the data, how will it be able to accept the instruction, how is it going to make action accordingly. And for the CLCD, what we have got on our board can either be configured in 8-bit mode or 4-bit mode. So if it is 8-bit mode, you're going to make use of all 8 data lines. And if it is 4-bit mode, you're going to make use of only 4 data lines. So we are going to use RD4 to RD7. So if you have to know whether you have used the 4-bit mode or the 8-bit mode, in order to identify, you can open the CLCD write function. And being in the CLCD write function, if you have return it like 4 bits at a time, or if you are transmitting one nibble of data at a time, if 1 byte of data has been given to the CLCD in 2 parts, then you can identify that it has been configured in 4-bit mode, else it must have got configured in 8-bit mode. So that is what we saw in the previous class, the complete configuration of the CLCD in 4-bit as well as 8-bit mode. And as said, today we are going to start with the next peripheral of the module, which is nothing but matrix keypad. Now, matrix keypad, in fact, is like a very similar concept as that of a digital keypad. So here also what you have is a tactile switch itself. It is a tactile switch which is used to build the matrix keypad, same as that of a digital keypad. So the keys, whatever we are going to use, the tactile switches, what we are going to use, is arranged in the form of matrix here, and hence the name matrix keypad. And these keys are not a part of the digital keypad. So they have to be configured separately. They have to be programmed separately. So they are not a part of the digital keypad. And because the keys are arranged in the form of matrix, we call it as a matrix keypad. Now, with respect to the key, the working principle of the key is going to remain the same. So nothing is going to differ. So how key is made, or how a tactile switch is made, how to read a key from the particular configuration, the state detection, the level detection, and let's say bouncing effect. Every minute thing associated to the keypad or associated to the tactile switch remains the same here also theoretically. Now, because concept wise we have known tactile switches in detail when we were discussing digital keypad, I'm not going to make you study all of them again in this particular chapter. So you should have the knowledge of pull up circuit. You should know pull down circuit. Is my voice breaking? Okay. So you should have the knowledge of pull-up circuit, the pull-down circuit. So why is it called as a pull-up circuit? Why is it a pull-down circuit? And which edge gets identified when a switch is pressed? Which level gets identified a switch is pressed? All of the basic concepts are going to remain the same. So we will not waste time in revising or rediscussing those concepts, because that is very familiar and we have discussed for a very long time by now. So edge triggering, level triggering, everything is going to remain the same. Now I have been saying that the keypad here is a matrix keypad, or I have been saying that the keys here, the switches here are arranged in the form of matrix. Now, what is a matrix in fact? Like, what do you consider when I say matrix in general? What concept comes into picture if it is a matrix? Yes. So it is always rows and columns. So you are going to arrange certain things in the form of rows and columns. So when we are speaking something with respect to the matrix, then we are saying things in terms of rows and columns. So here also I will have the keys which are arranged in the form of rows and columns, and hence the name matrix keypad. Now if I show you how the keys are been arranged on our board, so let me open the Pixim lab. If you can observe here, let me highlight the keypad. So this is the matrix keypad, whatever I'm highlighting. So starting from key number 1 to key number hash, so it's a matrix keypad. You can see keys are arranged in terms of rows and in terms of columns also. So this is the reason why we call the key as a matrix keypad, because it has been arranged in the form of rows and columns. Now, when we were discussing digital keypad, I said when we will use the matrix keypad, I will justify the statement. Is there anybody who remembers that statement? So I made a statement when it is in the digital keypad, and I said I'm going to justify that statement back when we go with the matrix keypad. So is there anybody who remembers the statement? In fact, if I have to give a hint, I made it with respect to the usage. So, which among the two will be used more? In what situation will it be used more? So, that is what the statement was referring to. Do you remember the statement? No? For interrupts, digital keypad? No. Okay, fine. So, let me re-repeat that statement. So, like whenever you have less number of user inputs, we are going to make use of digital keypad. And when we want more number of user inputs, then we are going to deal with matrix keypad. So I told you when user inputs are less, we choose a digital keypad, and when user inputs are more, we are going to choose a matrix keypad. So that was the statement made, and that was with respect to the number of user inputs you are going to take. Okay, so lesser the number of user inputs, digital keypad, more the number of user inputs, matrix keypad. So the same is being put here on the slide as well. Let us look into this matrix keypad. So used when more number of user inputs are required, and it is still going to save some of the controller's input output lines. So even though matrix keypad will be taken when user inputs are more, so first of all, more number of user inputs, you might be expecting it to consume more number of input output lines. But that's reversed in case of matrix keypad. More number of input output lines will not be used. So for more number of inputs to be read, it still uses lesser number of input output lines of the microcontroller. So that is one reason why matrix keypad is used. So the name is matrix keypad because the keys are arranged in terms of rows and columns. And the very commonly used application is in the telephonic application, in the calculators, in the digital lockers, and in many more. So these are some of the advantages where matrix keypad is actually being used. Now let us look at and understand how this matrix keypad is actually constructed, and why exactly will we be using matrix keypad if we have more number of user inputs. So we will see that. To start with, assume I have a switch here. Okay, so we are going to understand the interfacing of the matrix keypad. So for that, I'm going to first consider a single switch. So I have a switch taken here. It is a tactile switch, and you know the operations of tactile switch already. Now assume this is the switch I have taken. One end of the switch is connected to the microcontroller. Another end of the switch has been connected to the ground. So whenever I'm going to press the switch, what am I going to read at the pin of the microcontroller? Yes. So when I press the switch, current from the microcontroller is flowing to the ground via the switch. So I will be able to read a 0 at the pin of the microcontroller. Now, whenever the switch is open, what will I read? If the switch is open, what gets read at the pin of the microcontroller? Yes. So if the switch is open, the circuit is not complete. It's a floating line. And this floating line is going to absorb noise around it. It may absorb the electromagnetic waves around it. And because of that noise, you may end up seeing a 1 at the pin of the microcontroller. But the one what I end up seeing at that point of time is not a valid one. So that is because of the noise which is around the particular pin of the microcontroller. So I'm going to have one red, that is by chance. So I might not get one all the time. I may get one due to the noise being attracted. Now, how do you solve this issue? Yes, I have to add a pull-up circuit. Okay, so I'm going to add a pull-up circuit like this. So whenever the switch has been open, current from the VDD is made to flow into the microcontroller. So if the switch is open, what will be read at the pin of the microcontroller this scenario? Yes. So you are going to read a 1 if the switch has been open, and you are going to read a 0 if the switch is closed. So I'll make a note here. So O represents open. So whenever the switch is open, I'm going to read a 1 at the pin of the microcontroller. And if the switch is closed, I'm going to read a 0 at the pin of the microcontroller. Any doubt in this? All right. So let us proceed. So I took a single switch as of now to know what gets read when a switch is pressed and what gets read if a switch has been open. But do you think matrix keypad has a single switch? Do you think matrix keypad has a single switch? Obviously no, it has multiple switches. So let me add few more switches for this particular circuit. So I'm going to add few switches like this. Okay. Now let me make a statement here. So to start with, I have a pull-up circuit. So one end of the switch, I have taken 4 switches. One end of all the 4 switches are connected to a microcontroller in common. Another end of all the switches are connected to ground in common. Okay. So now assume I'm going to press none of the switches. Okay, I mean none of the switches are pressed. So what are you going to read at the pin of the microcontroller? So if none switches are pressed, so yes, if none switches are pressed, I'm going to read a 1 at the pin of the microcontroller. If no switches are pressed, then I will be reading a 1 because current from the VDD flows to the microcontroller. So I will read a 1 here. Now assume after some point of time, I have pressed switch 1. Okay, so I have pressed switch 1 after some point of time. Now what will be read at the pin of the microcontroller? Yes, so when switch 1 is being pressed, current from VDD flows to the ground via the switch 1. Okay, so from the VDD like this via the switch 1, it will flow to the ground like this, and hence I should be able to identify a 0 which is representing ground. So if none of the switches are pressed, I'm going to get a one seen. And if switch 1 is pressed, I'm going to read a 0 at the pin of the microcontroller. Now look at the difference and tell me again, assume none of the switches are pressed. If none of the switches are pressed, what will be read at the microcontroller? If none of the switches are pressed, I will be having one red. After some point of time, let's assume I'm going to press switch 2. Okay, so I'm going to press switch 2. Now what will be read at the pin of the microcontroller? Yes, So in that case, there will be a 0 red at the pin of the microcontroller. Okay, so there will be a 0 red at the pin of the microcontroller. Again, none of the switches are pressed. I'm going to read a 1. And if switch 3 is pressed, then also I will be able to read a 0 itself, right? So switch 3 pressed or switch 4 pressed. Any of the switches I'm pressing here, all the time I'm going to read a 0 at the pin of the microcontroller. Okay, so every time I'm reading a 0 at the pin of the microcontroller. Now see and answer. If this is the scenario, do you think you will be able to identify which switch is being pressed? If this is the scenario in your hardware, is there any differentiation you can make? I mean, will it be possible to check which switch is being pressed? So it is quite challenging to find out which switch is being pressed if this is the scenario. So I cannot in fact find out which switch is being pressed if the hardware circuit is formed like this. So what we see is here all the switches are commonly connected to VDD at one side and commonly connected to ground on the other side. So I can identify if switch is pressed or not. But it is not possible for me to identify which switch is pressed. Out of the 4 switches, I cannot identify which switch is being pressed. That is not possible. So if the hardware circuit is formed something like this, it is quite challenging. I would say it is quite not possible to identify which switch is being pressed. So what I can do as a substitute to this or as a solution to this problem, if I have to identify which switch is being pressed, whichever switch I want to identify, I will provide ground only to that particular switch. For example, if I want to identify whether switch 1 is pressed or not, I will provide ground only to the switch 1. So for rest of the switches, I will not be providing the ground. So observe the example here. So like this. I provide the ground only to the switch 1. Now assume none of the switches are pressed. What am I going to read at the pin of the microcontroller? If none of the switches are pressed, I am going to read a 1 at the pin of the microcontroller. Now if switch 2 is pressed, what will be read at the pin of the microcontroller? If switch 2 is pressed, this is switch 2, not switch 1. This is switch 2. One end is being connected to VDD, another end is also connected to VDD. So whether you press this switch or not, you will always read a 1 in case of switch 2. Similarly for switch 3 also, so I am going to read a 1 whether a switch is pressed or not. And that happens for the switch 4 also. But think of switch 1. If the switch is pressed, what will be read at the pin of the microcontroller with respect to switch 1? Yes, it will be 0. Okay. So out of all the switches in this kind of hardware connection, I will be able to identify only if switch 1 is being pressed. Okay. So I will check if switch 1 is actually being pressed in this particular logic. So don't you think this time I will be able to identify if switch 1 is pressed or not? I will be definitely able to identify, right? So I can identify if switch 1 is pressed or not. Now similarly, I want to identify if switch 2 is pressed or not. Out of all the switches available, I have to identify if switch 2 is pressed or not. So how will I be able to identify? Yes, I have to provide ground only to the switch 2. Okay, so I have to provide ground only to switch 2. So this way, if I provide ground only to switch 2, I will not be able to identify any other switches apart from switch 2. Only when switch 2 is pressed, you will see the signal falling down to 0. So if switch 1, switch 3 or switch 4 is pressed, you will not be able to see any operation. So you will be able to identify. Okay, So you will be able to identify if the switch has been pressed only with respect to the switch. Now similarly for switch 3, you can provide ground only to switch 3 to identify noise. Somebody's mic is on. Dhananjay, mic is on. Okay, that's muted. Yes. So I was telling. So whichever switch you want to identify, provide ground only to that particular switch. So I will provide ground to switch 4 here. I will be able to identify if only switch 4 is being pressed. Now, if the hardware connection is made like this, assume this is the hardware connection you find on the board. So only which switch will you be able to identify? If this is the hardware connection formed, so only which switch will be able to identify? Yes. So I can only identify if switch 4 is being pressed or not. Okay. So I cannot identify any other switches. I can identify only if switch 4 is being pressed. But in my matrix keypad, I cannot deal only with switch 4. Okay. So I may have to deal with multiple switches. In fact, I have so many switches on board. So I have to see which switch is being pressed. Okay, I have to identify which switch is being pressed on the circuit on board also. So if this is the scenario, okay, if I have to identify which switch is being pressed, I can provide ground according to my requirement. Okay, so to whichever switch I want to identify, I'm going to provide the ground here. Now in this scenario, assume I provide 1, 0, 1, 1. Okay, so ground to be provided means what should I give to the particular switch? In order to have a ground given, yes, I am going to give 0 for providing the ground. Now I am giving 1, 0, 1, 1. Okay, so I'm giving 1, 0, 1, 1. So if 1, 0, 1, 1 is given for the switches, which switch can I be identifying? I can identify only switch 2, right? Whenever switch 2 is pressed, I can identify. How will you confirm that I have pressed switch 2? How will you confirm that I have pressed switch 2 itself? Come on, how will you confirm if I have pressed switch 2 itself? Yes. So if switch 2 is pressed, this pin is falling down to 0. Okay. If switch 2 is pressed, this will fall down to 0 because current from VDD will reach the ground via the switch 2. So this input, okay, so sorry, this output will fall down to 0 whenever you are having switch 2 pressed. So if other switches other than switch 2 is pressed, that will not make any difference. You keep reading 1 itself. So only when the signal falls down to 0, I can identify here because ground is provided only for the switch 2. So I can identify that switch 2 is being pressed when the signal falls down to 0. So this way I can say which switch is being pressed by providing ground to the required switch. So similarly, if I provide something like this, 1, 1, 1, 0. So which switch will I be able to identify? Yes. So that will be switch number 4. So I can identify switch number 4 here. So that way you can provide ground only to the particular switch and you can identify if that particular switch has been pressed or not. Okay. So can you repeat the part where you said signal will fall down to 0 at the microcontroller, ma'am? Okay. So whenever a switch is pressed, the signal here is going to fall down to 0. Okay. So what happens here is, so whether you take switch 1 or switch 2, whichever switch you want to identify, if none of the switches are pressed, you will be reading a 1 here. Okay. So assume I'm going to provide 1011 here. So I'm providing 1011 to the switches. So if switch 1 is pressed, nothing is going to differ. You still read a 1 itself. If switch 3 is pressed, you still read a 1. Switch 4 is pressed, you still read a 1. Only if switch 2 is pressed, signal here is going to fall down to 0. So when signal falls down to 0, I can confirm that switch 2 is pressed because I provided ground only to switch 2. Okay. So that way, for the required switch which I want to identify, I can have the ground provided. But in case of our matrix keypad, I don't have a single column like this. So whatever you write vertically, they are columns. Whatever you represent horizontally, they are rows. If you look at this observation, how many columns do I have? If you look at this representation, how many columns do I have here? Yes, I have one column. And how many rows? How many rows are available here? I have 4 rows and 1 column. But in case of our keypad, I have 4 rows with 3 columns. Okay. So we have 4 cross 3. Yes, 4 rows with 3 columns. So let me add few more keys to it like this. Okay. Now before I add few more keys, assume I'm going to provide 1111 at the pins of the switches. To the switches I'm providing 1111. Which key will I be able to identify? Yes. So I will not be able to identify any of the keys. So none of the key gets identified because irrespective of whichever key you are going to press, because you have not provided the ground to any of the switch, so all of the switch, whether they are pressed or released, eventually are giving one red at the pin of the microcontroller. So that way I have added few columns here, okay, few keys and few rows and columns. So this is according to the circuit on board. I have 4 rows and 3 columns. Okay. So key number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So as of now, consider these are the key numbers. Now if I provide 1111 here, which keys will I be able to identify? If I am going to provide 111 here, which key will be identified? Yes, none of the keys will be identified. Now assume I provide 1, 0, 1 and 1. Okay. So assume 1, 0, 1 and 1 will be provided here. Okay. So in that case, which key can I identify? I am providing ground to key number 2. I am providing ground to key number 6. I am also providing ground to key number 10. Assume after some point of time, the third column here falls down to 0. Okay. After some time, the third column here is falling down to 0. So which key will be identified? 9, 10, 11, 12. You are providing ground only to the second row. So ground is provided to key number 2, key number 6, key number 10. Now if switch 2 is pressed, assume this is column 1. Okay. This is column 2. And this is column 3. Okay. So this is column 1, this is column 2, and this is column 3. So now, whenever I have provided ground to the second row, I will be able to identify key number 2, key number 6, and key number 10. Now, if C1 falls down to 0, so which key will I be able to identify if C1 falls down to 0? So if C1 falls down to 0, current from VDD is flowing to the ground via the switch 2. So I will be able to identify switch number 2. Now if C3 falls down to 0, which key will I be able to identify? Yes. So I will be able to identify switch number 10. Now let me give, see, I am only I can read 0 only at one of the column. I'm not supposed to read 0 in both the columns. I mean, you will not generally press two switches at the same time. Okay. So let me repeat again. Assume I'm going to provide 1, 1, 0 and 1 to the pin of the microcontroller. So that is to the switches. So first one is column 1, second one is column 2, third one is column 3. Now assume after some point of time, this column 2 has fallen down to 0. Okay. So after some point of time, this column 2 has fallen down to 0. So which switch do you think is pressed? Which switch is pressed? Yes. So switch number 7. So if I provide 0 here, I'm providing ground to switch number 3, switch number 7, switch number 11. So if column 1 falls down to 0, I have pressed switch 3. Column 2 falls down to 0, I have pressed switch number 7. Column 3 falls down to 0, I have pressed switch number 11. Are you able to follow this? Okay. Instead of providing 0 to column 1, column 3, we can press switch in row 2. That also gives. Yes, I am not providing column 1 and column 2 with 0. So column 1, column 2, column 3 are giving me 0 after a switch is pressed. So I'm telling when I have provided 1, 1, 0, 1 and after some time if column 2 falls down to 0, I'm asking which switch would have been pressed. So I'm not writing into columns. That is not allowed. So both need to monitor VDD and ground for identifying the switch pressed. We have to provide ground to particular switch only, and you have to keep the eye on the column. So whichever column falls down to 0 after you provide the ground, that particular switch gets identified. Okay. So now this is how the switch gets identified. But the problem with this is we don't have provide ground to respective switch and check the column value is enough. Yes. Okay. So I was telling if you see the circuit on board, we don't have the key number specified like this. Key number is going to get varied. So you can see this is the key number. Key number 1, 2, 3, 4, 5, 6, 7, 8, 9, star 0 and hash. Okay. So the rows, row 1, row 2, row 3, row 4 are connected to RD3 to RD0. Column 1, column 2, column 3 are connected from RB0 to RB2. Okay. So this is the matches keypad. Now, just for the sake of our convenience, to have a program written, let me have a small table created for this. Okay. Now, this is one circuit. I'm going to have it written here. Okay. So I'll have a table written just for sake of our convenience, for the sake of programming. So my matrix keypad has 4 rows and 3 columns. Okay. So first I write row 1. Okay. So first I have row 1, then row 2, row 3 and row 4. Okay. So row 1, row 2, row 3 and row 4. As of now, we are not seeing any pull-up circuit here. So just for the sake of this example, let me add the pull-ups here. Okay, so I'm going to add pull-ups here. So for each of the line, the pull-ups are missing. So I'm going to add pull-up here and I'm going to have a VDD return here. Okay, now coming to this. So I have 4 rows, row 1, row 2, row 3, row 4 and 3 columns, column 1, column 2, column 3. Okay. So row 1 is being connected to, let's say, RD3 pin of the microcontroller. Row 2 is being connected to RD2 pin of the microcontroller. Row 3 is being connected to RD1 pin of the microcontroller. And row 4 is connected to RD0 pin of the microcontroller. Column 1 is connected to RB0. Column 2 is connected to RB1 and column 3 is connected to RB2. Okay, so I just made a table here. Okay, so I have to identify which switch is being pressed. Okay, so I have to identify which switch is being pressed. Chaitanya, I had to ask you, like all of the points when I'm supposed to say it, you're already saying it. Is that because you have a work experience already? No? Or were you in some other batch? Till keypad you were already there in the other batch. So that is why, like when I have something to be said ahead, you will already be saying things. Okay. So anyway, let me start. Let me say this. So whenever I have to identify if a switch is being pressed, I have to be providing ground to that particular row and I have to keep an eye on the column. So first initially let me make R1 as 0. I'm providing ground to R1. Okay. So when I provide ground to R1, that is row 1, so I am going to have this provided to the rows. So 0, 1, 1. Okay. So now when I have provided 0, 1, 1, 1 to the 4 rows, which switch will I be able to identify? When I have provided 0, 1, 1, 1, yes, I will be able to identify switch number 1, 2 and 3. So I will be able to identify 3 switches. Now, so if the first switch is pressed, which column falls down to 0? If the first switch is pressed, yes, column 1 falls down to 0. All other things I'm going to get 1 itself. Now when I make row 1 as 0, and if I see column 1 falling down to 0, then can I conclude that I have switch 1 pressed? Can I conclude that I have switch 1 pressed? Yes. Again. So I have made row 1 as 0, and assume after some point of time, I'm making column, let's say column 2 is falling down to 0. So which switch gets identified this time? It is switch number 2. Similarly, I have made row 1 0, and after some point of time, let's say column 3 falls down to 0. So this is 1, this is 1, this is 0. So I'm going to have switch 3 identified. Okay. So next, I'm going to make row 2 falling down, like I'm going to provide ground to the row 2. So which switch will I be able to identify? Switch number 5, 6 and 7. So let me complete the table here. So this is 0. Okay, this is 0. This is 0. This is, let's say 1, 1, 1. Okay. So now, okay. So if row 2 is made 0 and column 1 is falling down to 0, which switch must have got pressed? That is switch number 4. So this one will be switch number 5 and this one will be switch number 6. So if I have provided ground to row 2, I will be able to identify whether switch 4 is pressed, 5 is pressed or 6 is pressed. So if column 1 is falling down to 0, I have switch 4 pressed. Column 2 falling down to 0, I have switch 5 pressed. Column 3 falling down to 0, I have switch 6 pressed. Similarly, assume I make R3 as 0. Which switches will I be able to identify? Yes, I will be able to identify switch number 7, 8 and 9. Okay, so this is 1, this is 0, 0, 0. So now if row 3 is provided with 0 and column 1 is falling down to 0, I will be able to identify switch number 7. Row 3 is provided with 0 and column 2 falling down to 0, switch number 8. And row 3 provided with 0, column 3 falling down to 0, switch number 9. So similarly, I'm going to make it for row 4 also. Okay, so this time I'm making row 4 provided with ground. So this is 1, 1, 1, 0, 0, 0. Okay, so if row 4 is falling down to, if row 4 is provided with 0, I will be able to identify star, 0 and ash. Okay, so if column 1 falls down to 0, I can say it is switch star. Column 2 falls down to 0, I can say switch 0. And column 3 falls down to 0, I can say switch number ash. So in my program also, if I have to identify which switch is being pressed, I have to implement this table. I have to first provide ground to switch 1 and I have to check which column is falling down to 0. Then I have to provide ground to switch 2 and I have to check which column is falling down to 0. So this table I have to be implementing in code in order to identify which switch is being pressed. Is that clear? Can you repeat star, 0 and ash? So I'm providing ground to row 4. So if row 4 is provided with ground, I will be able to identify switch number star, switch number 0 and switch number ash. So if column 1 is falling down to 0, I must have pressed switch star. If column 2 is falling down to 0, I must have pressed switch 0. And if column 3 is falling down to 0, I must have pressed switch number ash. Yes, that is the switch name. Did you get this? Any doubts in this table? Okay. So let us start with the coding part. We are going to implement the same in the code as well. So let us begin with the coding part. But before that, let us take a break of 2 minutes and start with the coding. Okay, let us start with the programming. Okay. So what we are trying to implement here in the project is we already have a template. So in the project, we are going to see which key is being pressed. So I'm going to have it displayed on the CLCD. Okay. So I'll display it on the CLCD as in which key is being pressed. So whether it is key 1, key 2, out of the 12 keys available, I'm going to identify which key is being pressed, and that as a message will be displayed on the CLCD. But remember one thing. So as I made a statement that whenever you have more number of user inputs, you are going to prefer using matrix keypad. You can observe here what is happening. So in case of digital keypad, okay, you have learned digital keypad. How many keys were forming a digital keypad? How many keys on our board was considered to be a part of the digital keypad? Yes, so I had 6 keys which were a part of the digital keypad. Now tell me, to have these 6 keys configured, how many switches, like how many input output lines did we use? How many input output lines were used to have the 6 keys configured on our board? Think. How many lines did we use? How many pins of the microcontroller did we use? RB0 to RB5, isn't it? For the 6 keys of digital keypad, we used 6 pins of port B, isn't it? So yes, we used 6 pins of port B to configure 6 keys of digital keypad. Now, as the number of keys are going to increase, the number of input output lines used will also be increased. So tomorrow, if I have 10 keys in the digital keypad, I will use 10 more keys. I mean 10 input output lines to have it configured. So if I have to use digital keypad, I may use more number of input output lines. If I want more keys to be a part of digital keypad, I'm going to use more number of input output lines. Now just understand, if I wanted 12 keys to be a part of digital keypad, how many input output lines would I require? I require 12 input output lines. Now look at the matrix keypad. I am still having 12 switches. But how many input output lines am I using altogether? How many input output lines am I using altogether? So I'm hardly using 3 plus 4, 7. So I'm using 7 input output lines to configure 12 switches. Now, don't you think I will be able to read more number of switches with just few number of input output lines? So that is why we say if there are more number of user inputs and you still want to save some of the lines of the controller, then you are going to configure a matrix keypad rather than a digital keypad. Okay. So that is what we discussed in the digital keypad. Now let us proceed with the programming part. As I said, we are going to say which switch is being pressed. I'm going to display it as a message on the CLCD. Now initially, before I start with the coding part, Syed is asking a doubt. In row 3, switch are there, then 2 enough, right, for 6 switches to represent. Can you repeat the last point? See, in this case, in case of matrix keypad, to have 12 switches configured, I'm using 7 input output lines only. But if you want the same 12 switches to be available in the digital keypad, you will need 12 different lines in the digital keypad. So, more the number of keys, more the number of input output lines in the digital keypad. But that is not the scenario in the matrix keypad. So, if you want, I can use one more line and I can configure 3 more switches. Okay. So, more the number of input you want to take from the user, you can have a matrix keypad use. Okay. So, before I start, let me speak about the direction of the pins which are connected to the rows and columns. So rows are connected from RD0 to RD3. Okay. So rows are connected from RD0 to RD3. Okay. Now if the rows are connected from RD0 to RD3, what should be the direction of RD0 to RD3 pin? What should be the direction of RD0 to RD3 pin? First of all, tell me how are these pins serving to this particular switches? So to the switches, how are these pins acting? To the switches, they are input. So switch is taking a 0 or a 1 as an input. So to the switch, RD3 to RD0 are input. So with respect to the microcontroller, what is it? It's the output. So switch number RD0 to RD3 should be treated as output. Then coming to the columns, so I have a switch number RB0 to RB2. Okay, so this is RB0 to RB2. Okay, now, so with respect to the columns, what is the direction? How is it acting with respect to the switch? How is it acting with respect to the switch? To the switch, it's an output, isn't it? To the switch, it's an output. So switch is giving out a 0 or a 1 with the help of these columns. So if the RB0 to RB2 is serving as an output to the switches, what about with respect to the microcontroller? It has to be input, opposite to it. So this is input. Okay. All right. Now let us start writing the code. So first of all, to make RD0 to RD3 as output, how will I be able to do it? I want to make RD0 to RD3 as output. So how to do it? How to set the direction of RD0 to RD3? Can you explain RB0 to RB2 direction again? See, this RB0, RB1, RB2 are serving as an output to the particular switch. So switch is giving out a 0 or a 1 if the switch is pressed or if the switch is released. So to the switch, RB0, RB1 and RB2 are serving as output pins. Okay. But with respect to the microcontroller, its direction is opposite. Hence, I am taking it as input. Okay. Tris D, Tris B is OR with 0x0F. Okay, RD0 to RD3. I have to make it as output. What will I do? Tris D and with 0x0F. And should I do with and? Output, okay. So output has to be 0. I mean, to say it as output, I have to write 0. So to set the direction of port D, I have to use its data direction register as trisD. Okay. Now let's say trisD is initially having x, 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 x. Okay. But I have to make RD0 to RD3 as output. So I have to make it like this, x, 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 x and 0, 0, 0, 0. So tell me which bitwise operator to be used and what should I do with? And, okay. So and with what? And with what? 0xF0, right. So 1, 1, 1, 1, 0, 0, 0, 0. So that is going to provide me x, 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 0, 0, 0, 0. So in order to set RD0 to RD3 as output, I have to write, let me maximize this. Okay. So to make it as output, I have to write trisD is equal to trisD and with 0xF0. Correct? So in order to set RD0 to RD3 as output, I have to write trisD is equal to trisD and with 0xF0. Similarly, I want to make RB0 to RB2 as input. Okay, I have to make RB0 to RB2 as input. So to set the direction of port B, I have to use tris B. So assume tris B has XXXX. So after I set the direction, okay, so I should end up getting RB0 to RB2 as input. So I should get XXXX X111. So what should I do? To make it one, which operator should I be using? So if you have to make it a 1, you have to use bitwise OR. So what should you bitwise OR with? 000000111. Okay, so that I'm going to provide, I'm going to get this. So in order to set RB0 to RB2 as input, you have to write tris B is equal to tris B OR with 0x07. Okay, this is OR. Are you able to follow this? Okay. So let me open the driver. I'm going to close this. So first of all, I am going to display which key is pressed on the CLCD. Okay. So I'm going to display it on the CLCD. Now, to which lines? Think and answer. To which lines of the microcontroller the data lines of the CLCD are connected? To which pin of the microcontroller the data lines of the CLCD are connected? Remember and answer. To which pin of the microcontroller the data lines of the CLCD are connected? Data lines. So the 8 data lines are D0 to D7. Where is it connected to? Yes, it has been connected to port D, RD0 to RD7, isn't it? So port D, RD0 to RD7. Now, if I use CLCD in 8-bit mode, will I be able to use matrix keypad also along with it? No, right? Because in case of matrix keypad, I want pins RD0 to RD3 to be treated as output. So I want pins RD0 to RD3 to be a part of matrix keypad. I cannot let RD0 to RD3 to be used by another peripheral. I cannot give it to the CLCD. Now, if I cannot give it to the CLCD, do you think I can configure CLCD in 8-bit mode? If I cannot give RD0 to RD3 to the CLCD, will I be able to configure CLCD in 8-bit mode? No. So I have to configure it in 4-bit mode because one pin can be a part of one peripheral at a time. So if I use the CLCD in 4-bit mode, the data lines I'm going to use is RD4 to RD7. Okay. Only RD4 to RD7 will be a part of the CLCD. RD0 to RD3 will be a part of matrix keypad in that case. So if you have to use matrix keypad and CLCD together, you don't have an option of using it in 8-bit mode. CLCD should be configured in 4-bit mode. Okay. So let us start with the programming here. So first I have main.c file. Okay. Now coming to the main.c file, first I have the init config function called. So control comes to the init config function. Now I'm doing the initialization of the CLCD. So that CLCD.c file, I have copied it from the driver code of the CLCD. To show you that I have configured in 4-bit mode, you can see the CLCD write function. So I'm giving the data twice. I'm not giving it one shot. So I'm giving it twice. So I have configured CLCD in 4-bit mode. Then I'm doing the initialization of the matrix keypad that is written in a separate.c file. So that is init matrix keypad function. Now matrix keypad column port DDR is nothing but tris B. So there is a macro. Let me open matrix keypad.h. Matrix keypad column port DDR is tris B. Matrix keypad row port DDR is tris D. So whatever I wrote here having tris B is equal to tris B OR with 0x07. The same I'm writing here. I'm doing tris B is equal to tris B OR with 0x07. I'm writing tris D is equal to tris D and with 0xF0. Okay. So I'm going to do the initialization of the of the direction of the pins of the matrix keypad. And if you see the circuit on board, okay, so here if you observe, can you see that VDD here is actually missing? Can you see VDD here is actually missing? That is because whatever columns I have taken, it is been connected to RB0, RB1 and RB2. The three columns are connected from RB0, RB1 and RB2. This port B, so let me show you that. Port B comes with a built-in an internal pull-up circuit which is actually inactive. So let me show that. I'm opening the data sheet and I'm going to show it with respect to the port B. Okay, so here I'll go to port B. Port B. So here you can see a statement. Each of the port B pin has a weak internal pull-up. So pull-up circuit is already there with each of the pins of the port B, which is generally inactive. Okay. A single control bit can turn all the pull-ups. Okay. So weak in the sense it is not active. So it is disabled. Okay. So it is like it is not in the active state. It must have been in the disabled state. So each of the pins of the port B has a weak internal pull-up. Okay. Now the single control bit can turn on all the pull-up. Okay. So a single control bit can actually turn on all the pull-ups. So which is that? This is performed by clearing the bit not of RBPU. Okay. So it's not of RBPU. You have to clear the not of RBPU pin in order to turn on the pull-ups. So that is what we have written here. I need pull-up of the port B. So I'm writing not of RBPU with the value 0. So they said I have to clear the RBPU pin in order to perform that operation. So that is why we have written not of RBPU with the value 0. Are you able to follow this? Okay. And after that, initially, I don't want to identify any of the switches. Okay. So I don't have to identify any of the switches. So for that particular reason, so I have taken 4 macros, row 1, row 2, row 3 and row 4. So row 1 is representing RD3, row 2 is representing RD2, row 3 is representing RD1 and row 4 is representing RD0. So that is according to the circuit which is available on board. Row 1 represents RD3, row 2 is connected to RD2, row 3 is connected to RD1 and row 4 is connected to RD0. So that is written here as the macros. Now if I don't want to identify any switch being pressed, what should I be providing to these rows? RD0 to RD3? Yes, I have to be providing it with 1. So that is what I have done here. So initially, I don't want to identify any key being pressed. So row 1 is high, row 2 is high, row 3 is high, row 4 is also high. High is representing 1. So I will not be able to identify any of the switch being pressed. Are you able to get this? Okay. Now coming back to the initialization in the main function, I have CLCD print matrix keypad on line 1 zeroth position. So I'll take CLCD here. Okay. So on the CLCD line number 1. So this is CLCD. It has two lines, line number 1 and line number 2. Okay, so this is, let's say, line number 1, and it is at the address 0x. Can you remember and tell me what is the address of line 1? And this is line 2. What is the address of line 1? Yes, 0x80 is the address of line 1, and 0xC0 is the address of line 2. Okay, now what did I say is CLCD print matrix keypad on line 1, 0th position. So how many positions will I have for each line of the CLCD? Position number starts from 1. How many positions will I have? Yes. So position, if it starts from 0, I will have 15 positions, 0 to 15. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So I am having matrix keypad displayed on line 1, 0th position. Actually, there is a space at the first. So 1 space matrix, 2 spaces keypad, and a space. So let me have that type. So I'm taking 16 characters only to be displayed, not more than that. So I will have a space first. Okay, then M. Then second position will have A. Then matrix. Okay, so matrix. Then 2 spaces. So 7th and 8th, I'll not have anything. So from the 9th position, there is keypad. K, E, Y, P, then A, D, and a space. Okay. So I have matrix keypad displayed on line 1, 0th position. Then after this, if you can observe, I'm coming back to the main function. I'm reading the key from the read matrix keypad function. Okay. I'm reading the key from the read matrix keypad function. So same as that of read digital keypad function, I have read matrix keypad function. I have to pass state or level as an argument. Now coming to the read matrix keypad function, if you can observe, okay, the logic is remaining same as that of your digital keypad. So if mode is level, I'm going to return key, else mode must have been state. So I have to return key for only once. So if key is not equal to all released and once, I make once back to 0 and return key, else if key is equal to all released, once is made back to 1. So this logic is not changing. But earlier, when we were returning a key from the digital keypad, what was it returning? So earlier, when I was pressing any of a switch, assume I pressed switch 1. What was returned from the read digital keypad function? If switch 1 was pressed, did I return switch 1 directly like that? Yes. So that was returning the port B value, which is 0x3e. That is right. So if switch 1 was pressed, 0x3e was returned. Switch 2 was pressed, some other macro was returned. So it was in turn returning the value of port B. So this time I want to identify which key is being pressed. So for that, I first identify which key is pressed, then I return the key. Okay. To identify which key is being pressed, I'm going to have a function return called scan keypad. Okay. To identify which key is being pressed, I return scan keypad. Now what scan keypad does is, whatever I wrote here as a table, the same is being implemented here. So you can observe, first I'm making R1 low. So you can observe line number 28. R1 is made 0. R2, R3, R4 are maintained to be 1. Now a small for loop is written, a blocking delay to avoid bouncing effect. Okay. Next, if column 1 is falling down to 0, okay, then I can conclude that it is switch 1 being pressed. So I am returning 1, integer 1. Okay, if switch 1 is pressed, I am returning integer 1. Now if column 1 is not low, I am checking if column 2 is low. If column 2 is low, I have to return 2. If column 3 is low, I have to return 3. If that is not the case, I will make row 1 as high, row 2 as 0, row 3 as high, row 4 as high. Now if column 1 falls down to low, I am returning row 4. Column 2 falling down to low, I return 5. Column 3 falling down to low, I am returning 6. So the same table I have implemented. So what this scan keypad function returns is, it returns integer 0 to 9. If any key is pressed between 0 to 9, it returns integer 0 to 9. If it is star or ash, it returns star or ash as it is. Okay. And if none of the keys are pressed, it is returning all released. Now assume I have pressed switch 1 of the matrix keypad. Okay, switch number 1 of the matrix keypad. So what will the scan keypad function return? What will the scan keypad function return if I have pressed switch 1? It returns integer 1. Okay, it returns integer 1. Now that integer 1 will be returned depending on level detection or state detection. Now assume it is level detection. So return key. What is key receiving here in the main function? It receives integer 1. Because I have pressed switch 1, it returns integer 1. That integer 1 is passed as an argument to the display function. Okay. I want to display that I have pressed key 1. So I am calling the display function by passing the key as an argument. Now it is integer 1. Do you think I will be able to print integer 1 directly on the CLCD? Can I print integer 1 directly on CLCD? No. CLCD represents character liquid crystal display. I can display only characters on it. Now, how can I convert integer 1 to character 1? How can I convert integer 1 to character 1? No, typecasting will not help. So typecasting will not consider it as character 1. 1 minus 48, no, 1 is 49. Okay, so yes, character 0 plus that integer value. So character 0 represents 48. So 48 plus 1, if I do, it is 49. Its character equivalent will get displayed on the CLCD. Okay, now see how I'm saying. See, if it is star and ash, they are of type characters. I can display it as it is. If it is other than ash and star, I have to convert it into an integer value. Now, if I have to explain how this display function is working, first to start with, okay, so this is line 2. So first, if key is not equal to all released, assume I have pressed key 1. So scan keypad gave me integer 1. Read matrix keypad also gave me integer 1. Display function also gave me integer 1 here. So I have collected integer 1. Now, key is not equal to all released is true. You enter into the if block. I am displaying key on line to 0th position. So this is line to 0th position. So key will be displayed. K, E, and Y. Okay, with 2 spaces. So position number 3, position number 4 is done. Next switch of key, I have entered 1. So I have case star, I have case hash, both of them are false. So I will go to the default case, put CH, key plus character 0 on line to 5th position. So key is 1 plus character 0 will give me character 1 that will be displayed on line to 5th position. So this is line to 5th position. I will have 1 return. Then I come out of the switch case. So then CLCD space pressed on line to 6th position. So space and pressed will be returned here. So P R, 1 second. So P R, then E, yes, yes, then E and B here. Okay, so that way pressed. So if it is not any of that, it goes to the else block and says no key pressed on line to 0th position. Now assume I have pressed star key. Okay. So when I call the read digital keypad function, read matrix keypad function, it comes here. So it will scan and find out that it is character star. Okay, it is star key pressed. So I'm returning character star. So this key returns character star. So control will come to the main function. Key receives character star. That character star will be passed as an argument to the display function. Now switch off key, star is a character. Directly star gets displayed on line to 5th position. If it is not star and dash, you have to convert it into integer. So I have a default case return for it. Else you can have star and dash displayed directly on 5th position of the CLCD. So like this, I will get which key is being pressed displayed on the CLCD. Are you able to follow this? Are you able to get this? Okay. So I'm building this. I have a warning. Let me ignore the warning and see the output directly. So build is still going on. Okay, build is being successful and loading is completed. So I'm going to see here. Okay, fine. So let me load the hex file. If function returns integer 1 to 9, then by receiving unsigned character key. So what else do you need? Well, you can write it as see, unsigned character is nothing but 1 byte integer. Character is also 1 byte integer. So you can, because it is only 1 to 9, can I not store it in 1 byte of memory block? So I can store it. So I'm collecting it into unsigned character. Let me load the hex file. So matrix keypad, then matrix keypad driver, distribute, default, production, the hex file. So you can see initially matrix keypad and no key press. Now I press switch 1, it is level detection. So as long as I have kept the switch pressed, I will see the message on the screen. So it says key 1 pressed. I release. I press switch key, switch 6. It says key 6 pressed. Then I release. I press star, key star pressed. Then key 0 pressed. Then key hash pressed. So whichever key you are pressing, long pressing, because it is level detection, As long as you have kept the switch pressed, you will see the message, else you will see no key being pressed. So that is how you are going to identify which key is being pressed out of the keys in the matrix keypad. Did you get this? Okay. So this in fact completes the next peripheral matrix keypad, because we didn't have to discuss everything from the scratch with respect to the matrix keypad. It was a simple topic. So this completes the matrix keypad peripheral. I have a small hands-on on matrix keypad. I think we will do it in tomorrow's class. So if that hands-on if we complete, then we will be left with one last peripheral, ADC, analog to digital converter. That also I'm going to start it in tomorrow's class itself. Okay. So tomorrow we will do one hands-on on matrix keypad and start ADC. If time permits, we will start with the programming of the ADC also, and we should be done with the peripherals. Hopefully from Thursday, I should start with communication protocols. Okay. So Thursday, if I start communication protocols, Friday, I will start UART. So next week, we will be done with the module. Okay, so by the end of next week, we will be done with the complete module. Yes, I2C and SPI is also there. Saurabh, like we will not cover all 15 sources of interrupt. Okay. So as of now, if you can see, we have covered pretty good number of interrupt sources. So you know external interrupt by now. You know three interrupts which gets occurred because of the timers itself. Okay. Then you get one more of like the three timers itself will give you three different interrupts. Then what else did we discuss? Okay, we will see UART, which will also give you a source of interrupt. We have ADC that also gives you a source of interrupt. So UART in fact has more than one source. Okay, so that way we will not cover all 15 sources. Maybe in our syllabus we will hardly see around 8 to 9 let's say interrupt sources, not 8 to 9, including in I2C I can say around 10 uh, interrupt sources we will see. CAN bus is in our syllabus. CAN, yes, we are going to have started. So CAN is there in on our syllabus. We don't have an hands-on for that. We don't have coding part for that. So CAN will be just a theoretical session. Ma'am, can you conduct one doubt clearing session before starting the communication protocol? Uh, please have your doubts asked. Like if there is literally too many doubts for you to get answered, like if you have too many doubts for me to be clearing, I can dedicate one session. So do one thing, like Thursday session, I'll let you know, like if the class is like half done, if I cannot start with communication protocols, I can invest some time in having your doubts clarified. So keep your doubts collected, and if we get time we will definitely discuss that. Okay, fine. So that is it for today. Please have your attendance mark before quitting.